Okay, alright. So now we want to look at the chain rule. Okay, this one is partial derivative of composite function. Okay, so for this case, let's say we have z equal to f(x,y), and at the same time, the function x and y have the single variable t. Okay, which is the x is xt and y is yt. Therefore, we have z equal to fxt yt. Okay, so this one is a composition function of a parameter t. Okay, so you should remember that this is different from before. Before this, okay, in the previous video, we have looked at the z equal to f x y only. Okay, meaning that the function is in terms of x and y only. Okay, this time, okay, we have now, okay, in this slide, we use z equal to f, and the function of x is in terms of t, and the y is in terms of t as well. Okay, alright. So now let's look at the example. Okay, we want to calculate the derivative of dz over dt. Okay, given the following theorem. Okay, so we have the theorem. Okay, if z is equal to fxy is differentiable, and x and y are differentiable function of t, then z is the differentiable function of t as well. Okay, maksudnya dia boleh differentiate with respect to t. Okay, so dz dt, so this is chain rule that we will use. Okay, since we have z, and this z is in term of x and y, and this x is in term of t, and y also in term of t. Therefore, in order to find dz dt, we need to find dz dx. Okay, dz dx here, and dx dt. Okay, plus dz dy, sorry, del, yeah, this is del. Okay, del z del y, and dy dt. Okay, in order to find the differentiation of z, okay, with respect to t. Okay, alright, example. Look at here. Suppose that z is x cubed y. Alright, so this z is f x y, but x is ln to x, meaning that x here is in term of t, and y also is equal to t squared cos t, where y is in term of t. Okay, therefore basically we can z is f x in term of t, and y also in term of t. Okay, therefore we can find dz dt. Okay, so dz dt, okay, we can use the chain rule and also the theorem too. Okay, so basically we know that, okay, so z is have the independent variables z, x and y, and also x is in term of t, and y in term of t. So remember, in order to get a dz dt, we can find the del z del x and del z del y, okay, multiply with dx dt and dy dt. Okay, So we can just write del z del x multiply with dx dt plus del z del y multiply with dy dt. Okay, alright. So now we will use this. Therefore, we need to find all the value here. Okay, so del z over del x is basically del x cube y. So we know that for this case y is constant, therefore we will have 3x squared y. Okay, for del z del y, so it is del y x cube y. So x this time is a constant, so we will have x cube. Okay, so now we want to find the dx dt. Okay, so we have x equal to ln 2t. Okay, so dx dt is equal to, for ln here it is 1 over 2t. So this is general, 1 over 2t. We need to multiply with 2. So we will obtain 1 over t. Okay, alright. Okay, so now for y, we have y equal to t squared cos t. So dy dt okay, so is equal to, for this case we need to use product rule. Okay, product rule. So we need to consider this is u, this is v. Okay, alright. So dy dt is equal to u v prime plus u prime v. Okay, so u is t squared, v prime is, we need to differentiate cos, we obtain negative sin t plus u prime is 2t multiply with v is cos t. Okay, so the answer will be dy dt is equal to negative t squared sin t plus 2t cos t. Okay, so therefore we can find the dz dt, which is, you just substitute into the formula. Dz over dt is equal to, dz dx is 3 x squared y. Okay, multiply with dx dt is 1 over t plus dz dy is what is it? Okay, so x cube. Alright, dy dt is the whole thing there, negative t squared sin t, okay, squared sin t plus 2t cos